Yellowstone Volcano next supereruption, and how NASA is helping USGS predict it. And then we know we have the GPS stations all over the world showing what the deformation is from the seismic information, not only for Yellowstone, but the GPS stations all across the world. And we're going to take a look at the inflation happening at Yellowstone from those GPS stations. Yellowstone caldera gets its label as a supervolcano due to its ability to inflict devastation worldwide should another supereruption occur. Some of the biggest supereruptions on Earth were from Yellowstone. Satellite images taken by the Advanced Spaceborne Thermal Emission and Reflection Radiometer, or ASTER satellite for short, are helping scientists to identify hotspots and rising magma in order to warn of any future events. And since 2004, Yellowstone National Park officials have been studying thermal features around the park, hoping to identify if the supervolcano may erupt again. And they have found new thermal features, especially on the northwest of the caldera and the lake. Now, though, thanks to the help of NASA and this ASTER satellite, they can get real-time information revealing any signs of a sudden rise in temperature below the surface, deformation, things like that. Greg Vaughn from United States Geological Survey, USGS, revealed back in 2012, he said, "This is technology and data that could be applied to any geothermal and volcanic areas around the world to monitor eruptions and maybe even predict volcanic activity." He said, "Most volcanoes are not monitored until they erupt, and I want to get ahead of that." He says taking data manually is a difficult thing to do because Yellowstone is such a huge area. And there's a lot of places that they can't trek to, obviously, especially in the months of snow cover, as we have now. He says it's hard to work, it's time consuming, and there are bears, not only bears, but buffalo herds. We've seen them on the Old Faithful live cam that we look at every once in a while. Now, researchers used thermal imaging from space to monitor roughly 10,000 geothermal features of the Yellowstone region. And as we know, the Yellowstone supervolcano has over 10,000 geothermal features and also 60% of the world's geysers. Finally, support my Patreon account. The daily posts are 5 videos daily, and they are totally different from what I have on my YouTube channel. Thank you so much for your support and that you find all my content so interesting. You'll find the Patreon account details in the description box. Dr. Vaughn and his team take images overnight to prevent picking up heat reflection from the rocks because of the sun, the solar radiation, and then they study them to identify any areas of concern. The supereruption, any future supereruption at Yellowstone is, of course, would be devastating for the world. And supereruptions have occurred 3 times in history: 2.1 million years ago, 1.3 million years ago, 640,000 years ago, and it's led some to suggest another supereruption is overdue. But researchers working for USGS stated this theory could not be farther from the truth. Their website reads, "First of all, one cannot present recurrent intervals based only on 2 values. It would be statistically meaningless. But for those who insist, let's do the arithmetic. 3 eruptions occurred 2.1 million, 1.3 million, and 640,000 years ago. The 2 intervals are thus 0.8, 0.666 million, averaging to a 0.73 million year interval. And again, the last eruption was 640,000 years ago, implying that we're still about 90,000 years away from the time when we might consider calling Yellowstone overdue for another caldera-forming eruption. Nevertheless, they said, we cannot discount the possibility of another such eruption occurring sometime in the future, given Yellowstone's volcanic history and the continued presence of magma beneath the Yellowstone caldera. It was previously revealed how researchers at University of Utah were left stunned when they discovered and produced images of a reservoir of hot, partly molten rock 12 to 28 miles under the surface. This hot rock is a chamber, and the chamber is 4.4 times larger than the shallower, long-known tunnel previously mapped out according to their study. Xinghua Huang, who led the research, said in 2015, "For the first time, we have imaged the continuous volcanic plumbing system under Yellowstone." He says that includes the upper crustal magma chamber we have seen previously, plus a lower crustal magma reservoir that has never been imaged before and that connects the upper chamber to the Yellowstone hotspot plume below. And despite popular belief, these magma chambers are not full of molten rock ready to erupt. Instead, it is mostly solid and sponge-like rock with pockets of magma. Jamie Farrell, co-author of the paper, emphasized that the discovery does not mean that Yellowstone is any closer to erupting. He said the magma chamber and reservoir are not getting any bigger than they have been. It's just that we can see them better now using new technologies. Fan Chi Lin, another co-author, explains, "It gives us a better understanding of Yellowstone magmatic system. We can now use these new models to better estimate the potential seismic and volcanic hazards." And this is by Callum Horn Express UK. Let's take a look at the GPS and deformation at Yellowstone. The geodesy, this map shows all the GPS stations worldwide. So if you're interested in finding out what is going on in your area, you can just find it on the map and examine what the GPS tells you about deformation from the Earth movements in your area. Now this is this is the satellite image of the GPSs in Wyoming, Montana, Idaho. We're going to look at. Okay, here we are. Let's go to this. And coming into the caldera area, we can see that's Yellowstone Lake, sitting on the southeastern part of the caldera, which is this thing here. You can even basically see the outlines of it. And this is Hebgen Lake, where we have a lot of deformation. Basically, most of the deformation takes place where the earthquake swarms have been going on around the northwest. So let's take one around the lake. Let's take one of these three. Hopefully they'll be good enough to look at. LDGE, that's not good. Sorry. Let's take this one. LA, and that's not even, well, okay, let's take that. That's deforming there. And take this one, LKW. Okay. This is going southwest. And we have a lot of deformation there. That's a good graph to see. Okay, this takes us from 1996 to today. You had a deformation there. Starting in 2005, you had a very big inflating area, a period of inflation. And then you had deformation, inflation, deformation. It looks like it's inflating again. As the geologists say, Yellowstone is heaving, it's breathing. But there's a lot of movement there. Let's take one to this area here. And again, it's going southwest, and that's pretty steady there. Let's take one in the middle of the area, in the caldera. That's not good, but still. It's all over the place. And let's head towards the northwest. That's Hebgen Lake, as we said. That's where we had the 7.3 magnitude earthquake in August of 1959. Okay, that's inflating there. That's right on top of the caldera. It's inflating. Let's head here towards Montana. Again, it's going southwest and it's inflating. And let's go a little bit towards Hebgen Lake. This one here. Okay, that's not a good one. Let's take this one here. Oh, that's inflating steadily since 2008, as we can see. And did we see this one or not yet? Yes. Okay, that's inflating as well. And let's go here towards Montana. And we'll go to Craters of the Moon because we had, that's inflating as well. And let's go to Craters of the Moon in Idaho. You can see the beautiful lava flows as well, very nicely there. Where are they? There they are. Okay. Look at the lava flows there, Craters of the Moon. And let's go take something around here. It's going southwest, and that's not inflating, it's sort of deflating. Let's take one around Boise, Dubois. It's going southwest, deflating, now inflating. As you're coming closer to Hebgen Lake, which is, where is it? It disappeared. Why can I not see it? Oh, there it is. Okay, right there. Okay. Did we take this? Red Rock. Okay, that's pretty steady towards inflating. But we see that they're heading basically southwest, and this is pretty steady here to seasonal. Okay, so basically we see that it's inflating, especially in the southwest area. There we go again, northwest, sorry. Okay, this is it right here. It's heading southwest and inflating. So all of you there are still visitors going there. There's been a lot of visitors that we saw during around Christmas, and it snowed over as we see, but it is inflating. This is one of the high threat supervolcanoes of the world. Please leave your comments. Thank you for your support.